Hey everyone, it is great to be here. As April mentioned, my name is Matthew Flaming. I'm the VP of Site Engineering at New Relic, which means I anchor our operations, infrastructure, and tooling teams. And I'm really excited to be kicking off the dynamic infrastructure track. I hope you're looking forward to the sessions today and tomorrow as much as I am. But before getting into that, I thought I'd pause for just a moment to set some context over how this space has changed in the past years. So let's spend a quality moment with our safe harbor slide. Okay, that was a quality moment. So if you're like me, back in the 90s, your first SaaS deployment might have looked a little bit like this. In my case, I was working at a baby content portal, and our stack was a massive set of 4 Sun 420R servers. The R is for rack mount. And we worried about things like hardware failures and OS upgrades and kernel patches and monitoring CPU and disk space and memory. Well, fast forward to the early 2000s, and instead of big Sun servers, we were racking pizza boxes, and lots of them. And the old concerns were still with us: hardware, OS, CPU, disk space, memory. But there were a new set of concerns that really came to the floor, and these were things largely around networking at scale, so SSL termination, DNS, load balancing, because again, we're operating at a much higher scale. Well then, mid-2000s, like a lot of people, I was involved in my first cloud-native startup, and this was fantastic because all of a sudden, we didn't have to worry about the hardware break-fix cycle or long provisioning times. But some of those old concerns were still with us around networking, OSs, CPU, disk space, memory. And there were a new set of concerns. These are things around noisy neighbors and much more complex deployments, because all of a sudden, there was this thing called service-oriented architecture, SOA, and everyone is rolling out lots and lots of open source components. So the topologies we're managing really grow in complexity. Today, like a lot of places that run at significant scale, New Relic is a hybrid cloud shop. Public cloud is fantastic for a lot of things. We leverage those. Private data center capacity is really useful in other ways, so we use that as well. And of course, that means even more complexity. And this is really the first key point that I want to home in on, that over the last decade, complexity has exploded in the infrastructure and operations space. Although we have much better tools, the reality is most of the old concerns are still with us. We still have to worry about CPU, disk space, and memory. We have to worry about networking. And the depth of the stack that operations teams run has really grown considerably. It's no longer just the hardware and maybe the OS. Now it's also the cluster orchestration layer and the hypervisor layer and the container layer. So again, massive complexity in the depth of the stack we're managing. The complexity is also increased, as Lou touched on, in terms of volatility. So now, we're facing an environment that changes much more. A decade ago, we thought about application and host lifespans in terms of years. Now we think about containers that might run for weeks or days or hours, and daily releases are the norm. At New Relic, we do dozens of releases most days. So all of this really frames a situation in which if we keep doing things the old way, we're going to get buried under a mountain of toil and technical debt. And this brings us to the theme of this track, this thing, dynamic infrastructure, which is brought about by the need for a paradigm shift, a new way of thinking about how we do operations and build infrastructure. So from one perspective, dynamic infrastructure is like this boogeyman that snuck up on us over the last decade and is making our lives miserable with all of these problems around scale, complexity, and volatility. But from another perspective, it's a set of requirements that frame a new way of thinking. And a lot of times, people will associate dynamic infrastructure with a very specific technology. They'll say, oh, it has to do with a public cloud or virtualization or containers. But what we've really found at New Relic is that dynamic infrastructure is, first and foremost, a design pattern. And there are really 2 key elements to this design pattern. The first is what Martin Fowler calls Phoenix servers. So the idea, of course, is you can burn down a server and recreate an identical server almost effortlessly. And this is the hedge against the toil associated with scale. The other aspect is thinking about compute as a uniform resource. So in my home, I have electricity, and I don't think, well, these electrons are going to the fridge and these electrons are going to my laptop. They just go where they're needed. Well, at New Relic, we think in terms of computrons, which is what our Metal as a Service team manufactures. And we work very, very hard to avoid any long-lived tight coupling between a particular workload and a particular set of computrons. So when our synthetics product needs to run more checks, well, it'll programmatically spin up more minions and assign a workload to those. Or when our process scheduler deploys a new service, it'll find the hosts that have available computrons and assign the workload there, and if that host goes away, well, it'll move those processes somewhere else. So these are really the building blocks that make possible a cattle versus pets mentality. These are really the core patterns behind that idea. And of course, this is, again, a wonderful way to deal with complexity, scale, and volatility. But what we found at New Relic is, even though we're dealing with cattle, we still need to keep track of our herd. In fact, it's become an even more urgent problem for us because all of a sudden, it's much easier to spin up a new service. And hosts look much more generic, which is why tagging and inventory management has become a first-class concern for us and is built into our infrastructure product. So when we spin up services, we make sure they're tagged not just with the project and feature they're associated with, but also the owning team. And we have automated auditing processes that will tear down instances that aren't tagged properly. So the other thing that we've really tried to embrace at New Relic is this idea of infrastructure as code. And of course, this is something that I expect almost everyone in the room has heard of. But we're really interested in the implications of this idea. So you wouldn't tell a software development team, I want you to build me a great product, but I want you to do it without a staging environment, or source control, or a mature build pipeline, or monitoring. But it turns out that's actually what we're asking operations teams to do all the time. We're not investing in a full, mature ecosystem around our infrastructure. So this is really something we're trying to drive towards at New Relic. We use the same sidekick and code review process for infrastructure changes as we do for software changes in our products. We use the same source control mechanisms. We schedule changes to deployments of infrastructure the same way we schedule software releases. So, if we're using a blue-green deploy pattern to release application changes, why aren't we doing the same thing to release server configuration changes? So this is the larger view of infrastructure as code. The other thing we've realized as we've moved towards a more dynamic infrastructure is that the opposite of this is true. That really, this is a team sport. So we're interested, for example, in being able to run our software in this standardized compute fabric. Well, that means we've been pushed towards building stateless services or services with replicated data. And it turns out this is a great pattern for scaling and reliability in general, so there's this virtuous cycle that gets set up. Similarly, we found a lot of benefit in building a rich and well-defined contract between our applications and our infrastructure. So, for example, by exposing things like standardized health check endpoints on our services or standardized shutdown hooks, we can really make our infrastructure do the right thing and automate away a huge amount of this toil. And the final thought I'd like to leave you with today is that, tomorrow's an inexact science. None of us really know what is coming next. But one of the amazing things about this dynamic infrastructure pattern is it sets us up so well to deal with those changes. And I think here at FutureStack, we're going to get some great glimpses of how to prepare for that future that is inexact, but we know is bringing more change, more scale, more volatility. We're going to hear great talks on operations and infrastructure. We're going to dive deep into that great ML-BAM operations mode that we saw earlier. We're going to get a glimpse in a lot more detail of the New Relic infrastructure tool from Jim Stoneham. And we're going to be hearing from Douglas Lee of AWS about building at hyperscale with AWS. So please sit back, enjoy the sessions. Welcome. It's great to be here.